Honors Geometry, Unit 4, Day number 1 notes. Okay, let's get right after it. We're going to be looking at polygons. It's mostly going to be quadrilaterals, but this first topic asks about naming polygons. So just very briefly, 2 things I want you to know about polygons. There are more qualities that polygons have to have, but the main 2, number 1, a polygon is a closed figure. And second thing I want you to know is that all the sides are actually line segments. You can't have any arc, okay? So that's what polygons are made of, okay? So they're closed, which means that both of the endpoints are connected to other sides, and the sides themselves are line segments. Right now, naming them, okay, hopefully you know most or even all of them, okay? I would think that most of you would know most of these. Okay, obviously a 3-sided polygon, we know that that's a triangle. Okay, 4-sided is a quadrilateral. And you could, I know you could Google these or just look them up, but we'll go through them quickly here. 5-sided is called a pentagon. 6-sided, do you know it? The witch left town. It's a hexagon, because, you know, witches make hexes. Hexagon. 7's one that most of you probably don't know, right? It's a HEP, H-E-P, Decagon. 8 sides, 8-sided polygon. Those of you that are into the UFC probably know about the octagon. Right? Or octopus has 8 legs. Octo just means 8. Okay? Another one that sometimes people don't know is the 9-sided, which is a non-agon. Is having a little trouble writing here today. That's okay. Okay. And then our good friend here, the 10-sided, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-sided figure. Okay, 10-sided polygon is called a decagon. So this is a decagon. Now this one, I think they skipped one here, and that's okay. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, see, most books include the 10 and the 12. They don't include the 11, which is okay. But just for the heck of it, that's a dodecagon. 12 sides. Okay. So 10 for decagon, 9 for nonagon, 8 for octagon, 7 for hep, 6 for hex, 5 for penta, 4 for quad, and 3 for triangle. Okay, with that in mind, this first topic should be pretty straightforward for you. All right, out of these figures, which figure is a hexagon? Well, which one has 6 sides? Okay, let's see. How about figure A? How many sides does this guy got? 1, 2, 3, 4, 5, 6. We got a 6-sider right there. How about this guy? 1, 2, 3, 4, 5, 6. No, this one's got 7. Right? That's a heptagon. And then this guy down here, C, 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. Okay, so which figure is a hexagon? Well, figure A is a hexagon. Which figure is an octagon? Well, remember, octagon has 8 sides. Okay, so the octagon is figure C. Which figure is a pentagon? Pentagon has 5 sides. None of those had 5 sides, so that was a none of the above. It's a reliable answer. Okay? It's legitimate. Okay, that's it for the first topic. Now, how many degrees are in the angles inside of a quadrilateral? Well, the easiest quadrilateral you could probably think of is a square or a rectangle, where you know that all of these angles are right angles. Okay, so if each of these is 90 degrees, 90 times 4 is 360. So that is what you're going to go on for this question here. The sum of all 4 angles on the interior of a quadrilateral will be 360 degrees, okay? At least if it's a convex quadrilateral, okay? So if these add up to 360, we're going to take the 129 and the 86 and the 73, and we can add them together. We get 288, and you could subtract that from the 360, and you find out that x is equal to 72 degrees. Okay? If you wanted to do it with algebra, you could have said x plus 129 plus 86 plus 73 equals 360, and then you could have done what we just did there. Combine like terms and subtract them. Okay, moving right along. So we just said that the sum of a quadrilateral, their interior angles, at least convex quadrilaterals, is going to be 360 degrees. And you remember from previous work, Unit 3, that the sum of the triangles, angles, and maybe even Unit 2 we had it as well, the angles inside of a triangle add up to 180. Okay, well, let's use that piece of information to figure out how many degrees are in this convex octagon. Okay? I'll get to the word convex in a second. We don't really need it for this because we have the picture. Okay, I'm going to start at one vertex. You can do this if you want. This is just to give you some rhyme and reason to the formula that I'm going to give you, right? So if I take this vertex and I connect that vertex to every vertex that is not consecutive with it. So like this one is right next to this one, that's consecutive. It's also right next to this one, that's consecutive. So other than those 2 other vertices, okay, I'm going to connect it to each and every other one. So I'm going to connect it to this one. I'm going to connect it to this one. I'm going to connect it to this one. Just drawing diagonals. I'm going to connect it to this one. I'm going to connect it to this one. So we did not connect it to those 2. As a result, how many triangles do we have? We have 1, 2, 3, 4, 5. We have 6 triangles. Triangles have how many degrees in their interior? We know it's 180. So this particular figure has 6 times 180 degrees. And let's see, 600 plus 480, that would be 1,080 degrees. Okay. Now, do we have to draw these triangles every single time? No. There's a formula that makes sense of this, okay? Actually, I think this makes sense of the formula, because what did we do? We took 180 and we multiplied it by, in this case, it was 6. How many sides are there? How many vertices are there? There were 8. So because it's the 2 consecutive sides that we don't make triangles from, you take those 2 away from the number of total sides or vertices and then multiply it by 180. That's what we just did. We took 8 for the octagon, an 8-sided polygon. We did 8 minus 2. Okay, 8 minus 2, and that's where we came up with 6. So that works with any polygon. Any polygon. You take the number of sides, n, subtract 2, and then after you've subtracted the 2, so we're going to do that first, that's why I'm putting it in parentheses. N minus 2 times 180, that's the formula for the sum of interior angles of a convex polygon. Okay, now I'll stop right here on the convex part. What is a convex polygon? Okay, well, convex just means that all of these angles, if you think of the vertex as pointing, being like a pointer, they're all pointing away from the interior. Right? This is pointing that way. It's not pointing in here. This angle is pointing this way. It's not pointing toward the inside. So what's a non-convex look like? Well, that thing there, that is a non-convex polygon, because if you take a look, this angle right here, it points this way, which is in, okay? If it points in, it caves in. That would be a concave polygon, okay? Convex polygons have all the angles pointing out away from the interior. Concave has one or more angles caving in to the interior. Okay, if you've ever seen a roof cave in on like an old barn, okay, it just flops right in towards the inside. Okay, so these formulas that I'm giving you are good for any convex polygon. So n minus 2 times 180 is for convex polygons. So that's an interior angle theorem. Okay, now we're going to take that information and we're going to find the number of sides if they give me the sum. So it's the complete inverse of that. So here they gave us the number of sides was 8, but then they said, we want you to take that piece of information. We gave you the n. We want to know the total number of degrees inside the polygon. Now they're going to give us the total number of degrees. So here's my formula again. Number of sides minus 2 times 180 equals total interior degrees. Well, they gave us this. The sum of all the angles inside of some convex polygon is 2,160 degrees. So I'll go n minus 2 times 180 equals 2,160. Cool. All right. So we could do this a couple ways, right? The way that you probably would think about back in your Algebra 1 days would be to take the 180, multiply it by both of these terms, distributing it, okay? Okay, then you can add 360 and divide by 180. Okay, that's very sound. I have no problems with that whatsoever. But since this is honors geometry, I'm going to show you how I would do it, which I think is just a little bit quicker, maybe a little neater, a little less sloppy. Okay, check this out. This set of parentheses is being multiplied by 180. I'm going to cancel the 180. I'm going to divide this whole side by 180. And I'm going to divide this whole side by 180. That gives me n minus 2 equals, let's see, what is this, 12? 360 plus, yep, 12. Check that out. I hope somebody likes this. So that tells me that the number of sides of that convex polygon must have been 14. Okay, so if there are 2,160 degrees inside of a convex polygon, then that polygon has 14 sides. The converse is also true. If a convex polygon has 14 sides, then its interior sum for angles is going to be 2,160 degrees. Okay, but you're using that formula, you're just substituting in the total instead of the n. Okay, moving along. We're going to take that piece of information that we just did, the n minus 2 times 180 equals the sum, okay, equals interior sum, okay, angle interior sum. Okay, and we're going to now look at this question. Well, there's one x. That's all they want. All they want is the x. If you remember back to this question here, we knew that the sum was 360. We just added up the angles that we did know and subtracted from 360. Well, wouldn't it be great if we knew the sum of the interior angles of this convex hexagon? We should know it, right? We should be able to do that. So since it's a hexagon, that would be 6 minus 2, or 4, times 180. And 4 times 180 is 720. Times 4 is 32, yep. 720. So I know that the sum of all of these angles in the interior of this convex hexagon is 720 degrees. So now I'm going to do what I did with that previous one. I'll write it out algebraically for this one. So x plus 120 plus 145 plus 86 plus 138 plus 112 equals the entire sum, which we just figured out is 720 degrees. So step one, we have to know the sum of all the interior angles, and then step two, we could subtract the ones that are not x. Okay, so let's combine like terms here. We got x by itself, or at least x as a non-like term. So 120 and 145 and 86 and 138 and 112. We add them together, 601 degrees equals 720. Okay, well now we know that. I mean, this is the easy stuff here. So that tells me that x is going to equal 119. And that's a reasonable number. It's definitely, it's between 0 and 180. We don't look at the picture because we always have to assume that the picture may or may not be drawn to scale. But 119 degrees, pretty reasonable answer. That's how we got it. Okay, moving along. Finding the measure of one interior angle and one exterior angle of a regular polygon. Okay, let's do the interior angle because we just worked on it. The exterior one's actually easier, and I'll show you that in a second. But let's do this. Let's find interior angle. Okay. So we know that an interior angle of an n-sided polygon, okay, the sum of all the interior angles is n minus 2 times 180. But what if this is a regular polygon? Okay? Regular just means that all the sides and therefore all the angles are congruent. So that means I have n angles. So if I took n minus 2 times 180 and I divided it by however many sides we've got, that will give me one of the interior angles. One interior angle of that polygon, if it's regular. If all the angles are different, you can't use this, okay? But if all the angles are congruent, meaning it's a regular polygon, then you can say n minus 2 times 180 is all the angles, divide it by how many sides or angles there are, and you get one of them. Okay? So let's find that out for this 20gon. Okay? So if the number of sides is not 3, 4, 5, 6, 7, 8, 9, 10, or 12, we just use the number of sides dash gon. So if I want to give you a 52-sided figure, I would call it a 52 gon. Okay, 71 gon. Okay, let's get this question gone. All right, so 20 gon, let's substitute 20 for n. So 20 minus 2 times 180 divided by 20. All right, so 20 minus 2 is 18. That's 180 divided by 20. Okay, those of you that want to just put it in your calculator and do it, I guess you can, but I'm going to cancel the 20 and the 180. 20 is a factor of 20 by 1. 20 is a factor 180 by 9. So 18 times 9 is, what's that, 90 plus 72, so 162 degrees. So one interior angle of a 20gon is 162 degrees. Okay, that's an interior angle. Now the question said, find the interior angle. We did it. But it also said, find the exterior angle. So check this out. If you are going to, for example, if this were a triangle we were looking at, and we know that these are 60-degree angles if it's a regular triangle. Regular just means all the sides are angles we can congruent, right? And an exterior angle is formed by taking one of these sides and extending it. Now, what is the measure of this guy right here? Well, we do have the extended angle theorem that we learned a little while back, Unit 3, that you could take the remote interior angles, find their sum, and you get 120. Or you can just remember from Unit 1 that this angle and this angle add up to straight line. They're a linear pair, so therefore 120. They're a linear pair. I wonder if that's true for quadrilaterals, like squares. If I extend this side, is the interior and the exterior angle a linear pair? Do they form a linear pair? Yeah, they do. Okay, so if you know that, once you find that interior angle, all you have to do to find the exterior angle is say, I know that they are a linear pair, so 180, subtract 162, 18 degrees, okay? Because even if it's got 20 sides, okay, let's say it's got 20 sides, I'm not going to draw all of them, but whatever the side is, if I just extend it, this interior angle and this exterior angle have to add up to 180. They have to add up to 180. All right. Hopefully that makes it pretty simple. Right? Wouldn't it be nice if it were simpler? Your wish is about to be granted. Because the exterior angles, I'll just give you this little piece of information. It's going to be extra as a shortcut. If you don't want it, don't write it down, but it's true. The exterior angles have a sum. The sum of the exterior angles is always going to be 360 degrees. And it doesn't matter how many sides there are. Okay? It doesn't matter. We just saw that the exterior angles of the triangle, okay, for the equilateral triangle were 120. Well, that's 360 divided by 3. It's 120. Well, for a 20gon, 360 divided by 20, guess what it is? It's 18. Boom. So in reality, what we did by finding the interior angle, it's good practice. It's good practice for those previous topics, but the exterior angle is much faster. So we could have done this. This could have been how we do this question. So I'm going to do this question again. All right? Hopefully you've written this down because I'm about to erase it. Okay, don't get upset. Don't get upset. You can rewind it. It's all right. It's okay. Be fine. So if I said I want to find one exterior angle of this regular convex, well, it has to be convex if it's regular, 20gon, then I would simply say 360 divided by 20 is 18 degrees. Okay, now how do I find an interior angle of a regular 20gon? Well, simple. I know that the interior and the exterior angles form a linear pair. Done. Done. Isn't that cool? So if you like the first way and you just want to practice finding the interior angles with the n minus 2 times 180 over n, no problem. But if it's a regular polygon, you can find the exterior angle and then just subtract it from 180 and you got the interior angle. Right? So honors people, I want to give you a couple different ways to do these things, right? And let your brilliant little minds get right after it and you choose which one you want to use with which question. All right, let's do this next question. Is this the last one? Oh, it is. That's awesome. So finding the number of sides. Okay, so now we're going to find the sides if they give you an interior angle. Right? So a couple ways we can do this one. Guess what? I'll show you 2 ways. Show you both of them. You get to choose. Okay, so the measure of each interior angle is 160. Each. That means one of them. So you can go back to n minus 2 times 180 divided by n. So this is the sum of all the interior angles divided by how many angles there are. Right? And you say, according to this, it's equal to 160. Okay? Completely legitimate way to figure out the number of sides, because number of sides is just n. They say find the number of sides, that's n. So let's briefly do this, okay? Let's multiply both sides by n. For those of you that like to cross multiply, it's doing this right here. So I'm going to multiply 1 by n minus 2 times 180. Now I'm going to multiply 160 by n. Okay. Now I'm actually going to do the distributive property because I think it's going to be a little easier if we set it up like this. So this will be 180n minus 360 equals 160n. Okay. Now I would like to subtract 180n from both sides. That leaves me with minus 360, which is negative 360. 160n minus 180n is negative 20n. And now I will divide by negative 20 so that I get n isolated. So negative 360 divided by negative 20 is positive 18. So if it's a regular polygon and the interior angle, one of them is 160, then it must be an 18gon. Okay. Not terribly difficult, right? Push pause if you want to copy it down because I'm about to erase it. Here we go. I mentioned to you that finding interior angles is legit, but finding exterior angles is easier. Check this out. If I know that one interior angle is 160, well, how big is each exterior angle? Well, it's going to be a linear pair with 160. So 180 minus 160 tells me that one exterior angle is going to be 20. Okay, how can I use that? Well, 360 divided by the number of sides gives me one exterior angle, which I just said is 20. So if I multiply both sides by n, or cross multiply if you want, you get 20n equals 360, and then you divide by 20. N equals 18, like we knew it would. So if you like the first way, use it. If you like the second way, use it. Day one is in the books. Either way you use it. See ya.